Hi students, welcome to SSV Spoken English Training Computers and Computer Exam Coaching Center near HOSPET, Ramatakis Road near Abhayanjaniya Temple. Okay, so ಈ ಒಂದು ಕ್ಲಾಸ್ ಏನಪ್ಪ ಅಂದರೆ ನೀಟು JEE KCET ಮತ್ತು DCET ಎಕ್ಸಾಮ್ಸ್ ಬರುವ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೂ ತುಂಬ ಉಪಯುಕ್ತವಾಗಿರುತ್ತೆ. ನಾನೇನು ಮಾಡ್ತಿದ್ದೀನಿ ಅಂದರೆ PUC ಫಸ್ಟ್ ಇಯರ್ ಫಿಸಿಕ್ಸ್ ಸೈನ್ಸ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಕನ್ನು ಲೆಸನ್ನು ನಿಮಗೋಸ್ಕರ ಪಾಠ ಓದ್ತಾ ಇದ್ದೀನಿ. ಸೊ ನೀವೇನು ಮಾಡಿರಿ, ಇದನ್ನು ಕೇಳ್ಕೊಳ್ರಿ. ಓಕೆ, ಯು ಕ್ಯಾನ್ ಕಮ್ ಟು ನೋ ಅಬೌಟ್ ದಿ ಪ್ರೊನೌನ್ಸಿಯೇಷನ್ಸ್. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ದಿ ಚಾಪ್ಟರ್ 1 ಫಿಸಿಕ್ಸ್, ಫಿಸಿಕಲ್ ವರ್ಲ್ಡ್. ಓಕೆ, ಸೊ ವಾಟ್ ಈಸ್ physics? So in this chapter you are going to learn what are the outcomes here, what is physics, then scope and excitement of physics, physics technology and society, fundamental forces in nature, ಮತ್ತು ನೇಚರ್ ಆಫ್ ಫಿಸಿಕಲ್ ಲಾಸ್, ಆಮೇಲೆ ಸಮ್ಮರಿ ಇರ್ತದೆ ಮತ್ತು ಎಕ್ಸಸೈಸ್ ಇರುತ್ತೆ. ಓಕೆ, ನಾವು ಲೆಟ್ ಅಸ್ ಗೋ ಬೈ ದಿಸ್. ಸೊ ವಾಟ್ ಈಸ್ ಫಿಸಿಕ್ಸ್? ಹ್ಯೂಮನ್ಸ್ ಹ್ಯಾವ್ ಆಲ್ವೇಸ್ ಬೀನ್ ಕ್ಯೂರಿಯಸ್ ಅಬೌಟ್ ದ ವರ್ಲ್ಡ್ ಅರೌಂಡ್ ದೆಮ್. The night sky with its bright celestial objects has fascinated humans since time immemorial. The regular repetitions of the day and night, the annual cycle of seasons, the eclipses, the tides, the volcanoes, the rainbow have always been a source of wonder. The world has an astonishing variety of materials and a bewildering diversity of life and behavior. The inquiring and imaginative human mind has responded to the wonder and awe of nature in different ways. One kind of response from the earliest times has been to observe the physical environment carefully, look for any meaningful patterns and relations in natural phenomena, and build and use new tools to interact with nature. This human endeavor led in course of time to modern science and technology. The word science originates from the Latin verb scientia, meaning to know. The Sanskrit word vignan and the Arabic word ilm convey similar meaning, namely knowledge. Science is a broad sense, is as old as human species. The early civilizations of Egypt, India, China, Greece, Mesopotamia, and many others made vital contributions to its progress. From the 16th century onwards, great strides were made in science in Europe. By the middle of the 20th century, science had become a truly international enterprise, with many cultures and countries contributing to its rapid growth. What is science and what is the so-called scientific method? Science is a systematic attempt to understand natural phenomena in as much detail and depth as possible, and use the knowledge so gained to predict, modify, and control phenomena. Science is exploring, experimenting, and predicting from what we see around us. The curiosity to learn about the world, the unraveling and secrets of nature is the first step towards the discovery of science. The scientific method involves several interconnected steps, systematic observations, controlled experiments, and qualitative and quantitative reasoning, mathematical modeling, prediction and verification or falsification of theories. Speculation and conjecture also have a place in science, but ultimately a scientific theory to be acceptable must be verified by relevant observations or experiments. There is much philosophical debate about the nature and method of science that we need not discuss here. The interplay of theory and observation or experiment is basic to the progress of science. Science is ever dynamic. There is no final theory in science and no unquestioned authority among the scientists. As observations improve in detail and precision or experiments yield new results. Theories must account for them, if necessary, by introducing modifications. Sometimes the modifications may not be drastic and may lie within the framework of existing theory. For example, when Johannes Kepler 1571 to 1630 examined the extensive data on planetary motion collected by Tycho Brahe 1546 to 1601, the planetary circular orbits in heliocentric theory, Sun at the center of the solar system, imagined by Nicholas Copernicus 1473 to 1543, had to be replaced by elliptical orbits to fit the data better. Occasionally, however, the existing theory is simply unable to explain new observations. This causes a major upheaval in science. In the beginning of the 20th century, it was realized that Newtonian mechanics, till then a very successful theory, could not explain some of the most basic features of atomic phenomena. Similarly, the then accepted wave picture of light failed to explain the photoelectric effect properly. This led to the development of a radically new theory, quantum mechanics, to deal with atomic and molecular phenomena. Just as a new experiment, many suggest an alternative theoretical model. A theoretical advance may suggest what to look for in some experiments. The result of experiment of scattering of alpha particles by gold foil in 1911 by Ernest Rutherford 1871 to 1937 established the nuclear model of the atom, which then became the basic of the quantum theory of hydrogen atom given in 1913 by Niels Bohr 1885 to 1962. On the other hand, the concept of antiparticle was first introduced theoretically by Paul Dirac 1902 to 1984. In 1930 and confirmed 2 years later by the experimental discovery of positron anti-electron by Carl Anderson. Physics is a basic discipline in the category of natural sciences, which also includes other disciplines like chemistry and biology. The word physics comes from a Greek word meaning nature. Its Sanskrit equivalent is bhautiki, that is used to refer to the study of the physical world. A precise definition of this discipline is neither possible nor necessary. We can broadly describe physics as a study of basic laws of nature and their manifestation in different natural phenomena. The scope of physics is described briefly in the next section. Here we remark on two principal thrusts in physics: unification and reduction. In physics, we attempt to explain diverse physical phenomena in terms of a few concepts and laws. The effort is to see the physical world as manifestation of some universal laws in different domains and conditions. For example, the same law of gravitation given by Newton describes the fall of an apple to the ground, the motion of the moon around the sun, earth, and the motion of planets around the sun. Similarly, the basic laws of electromagnetism, Maxwell's equations, govern all the electrical and magnetic phenomena. The attempts to unify fundamental forces of nature, section 1.4, reflect this same quest for unification. A related effort is to derive the properties of a bigger, more complex system from the properties and interactions of its constituent simpler parts. This approach is called reductionism and is at the heart of physics. For example, the subject of thermodynamics developed in the 19th century deals with bulk systems in terms of macroscopic quantities such as temperature, internal energy, entropy, etc. Subsequently, the subjects of kinetic kinetic theory and statistical mechanics interpreted these quantities internal of the properties of the molecular constants of the bulk system. In particular, the temperature was seen to be related to the average kinetic energy of molecules of the system. So I completed the first chapter up to 1.1, dear students. So you listen this and you can practice for your exams. Okay, thank you. We'll see in the next class. Welcome.